So we've learned about the mean, median, and mode. And now we're going to look at some more details, in particular quartiles. So the median is the value right in the middle. And then we have quartiles which say in the middle of the first half is your first quarter. We'll call that our first quartile. 50% is your median. 75%, we'll call that your third quarter or your third quartile. So it's just cutting your data in smaller chunks again. So we call the lower quartile or the first quartile Q1. And these quartiles and where things are at, I'm trying to think, probably the time that, like it says, it's often called the 25th percentile. The time that this comes up the most in someone's life is when they have a child that's young, right? Your parents are never comparing you now that you're in grade 12 like, oh, the 70th percentile for height. Better feed them different food at home. But when you're little and when you were a baby, your parents were like, ooh, all these measurements. It's easy to compare people when they're like really little and it's like, oh yeah, they're in the, you might hear people saying, they were in the 95th percentile for weight. That's like, that was a heavy baby. So that's probably in real life where you see ideas of percentiles come up quite a bit. The second quartile is actually the median or the 50th percentile. Then we have our third quartile or upper quartile. We've learned about the range, the difference between the biggest and the smallest values. And there's also the interquartile range, the IQR, which is the range between the first quartile and the third quartile. And then something very important for statistics is something called an outlier. So an outlier is an extreme or distant value. Okay? If we did height in this class, there would be no outliers. But if there was someone in here that was 7 feet tall, comparatively to everybody else, we would go, whoa, that's different. That would be what is considered an outlier. And there's a mathematical formula for figuring out if something is an outlier or not. Any value that is at least 1.5 times the interquartile range, either above Q1 or below, above Q3 or below Q1, would be an outlier. So, if I had the following list of data, these are 5 of you got test scores or quiz scores, and we had a 20%, a 50%, a 60%, and 70%, and an 80%. So the 20 seems to be really low. Is it low enough to be considered an outlier or not? Okay? Oh, I'm going to do 21, so we don't get a value like, oh, it perfectly works out to be right on the line. Okay? So, can you see that this is your median? Okay? That, where would be quartile 1? Right here. Where, because now there's 2 values above, where would be quartile 3? right there. Okay? If you wanted to, oh, this might be helpful. You know how we had formulas for finding the median? I had told you the position of the median was n plus 1 divided by 2. Do you remember when we did that formula? The position of the first quartile would be n plus 1 divided by 4, and the position of the third quartile would be n plus 1 divided by 4 times by 3. So I have 5 terms. Some people are very tempted to make the 50 quartile 1. Because you're like, oh, it's between the first and the third one. But it's not, it doesn't work out perfectly that way. I have 5 terms. If I add 1 to that, I get 6. 6 divided by 4 is 1.5. So that's why my quartile 1 is right there. So I have to take the average of these, 71 divided by 2. This quartile 1 is 35.5. Between 70 and 80, this would be 75. My interquartile range in this example would be 39.5. And 1.5 times 39.5 is about 60. I would have to have a score of 135 or a negative score in this example to be considered an outlier. So yes, the 21 is a low score, but it's not low enough to be considered an outlier. Okay? Whoa, did I skip a lot of questions? Here we are. There we go. All right, so first of all, we have to rearrange our data. 3, there's 1, 4, 2 5s, 1 6, 2 7s, an 8, and a 9. See that there's 9 data points? And we have 9 data points, and now I've rearranged them from smallest to biggest. If there are 9, the position of your median would be the 5th one. 9 plus 1 is 10. There's my median. If your median is a number, you can imagine it taken out. I have 4 numbers below, 4 numbers above. If you have 4 numbers, is there a middle of 4 numbers? No. And so your quartile 1 will equal 4.5. And your quartile 3 will equal 7.5. Your interquartile range, 7.5 minus 4.5, is equal to 3. So to get something that would be an outlier here, if I take 3 and I multiply it by 1.5, which would give me 4.5, I would have to be more than 4.5 above 7.5, or less than 4.5 below 4.5. And that would determine whether something would be considered statistically an outlier in this data. Second one, if we arrange these, 10, I've got 2 11s, a 12, a 13, a 15, an 18, and a 25. Two, 4, 6, 8 data points. Makes sense that your median would be 12.5 because we have an even number. And when your median is an even number, there's still 4 below it and 4 above it. So quartile 1 would equal the average between 11 and 11. Extremely difficult math. And then your quartile 3, average between 15 and 18, which is 16.5. Interquartile range, 16.5 minus 11 is 5.5. Is 25 an outlier? Well, if we take 1.5 times 5.5 and add it to quartile 3, we find out that yes, 25 is an outlier. So outliers do not necessarily show up how you would, like, maybe your gut feeling. Like when I gave those percentages at the beginning, you're like, ooh, that person with the 20, that seems bad compared to the other scores. It must be an outlier. So our personal experiences come into effect that we don't feel like people are getting 20s very often. So it feels like an outlier for that reason. Question? The 1.5 is part of the formula. And the outlier formula is not on your formula sheet. So it's like, what are some of the things that students forget when they get to their exam? The outlier question, because it's like a little detail. And it's like a weird number, like why 1.5? How is this decided upon? Use our calculator to verify the results. So you can put this data into your calculator, into list 1, and then do the VARS stats. So again, this is a very calculator-heavy unit, so we have to be able to take information. So I'm going to go to stat. I'm going to edit. If I have data, I go clear down, clear down. Clear down. And I'm going to quickly put in the data just from the second one, the 25, 11, 18, 10. And when you put in the data, it doesn't have to be in the right order in your calculator. It can be, got those 8 data points. So if I go stat and then I calculate statistics, I had my frequency from a grouped frequency data from before. So on my calculator, I have to change my frequency back to 1 because I have no frequency in the second part. I'll go to frequency list. There is no frequency list. I just clear it, delete it. Wow, stat, calculate. There. I guess I don't write, it's a list, I just delete it, hit calculate, and now I have quartile 1 at 11, quartile 3 at 16.5, median at 12.5, my min and my maximum, they all show up on my calculator. Are we going to be able to figure out a way to see an outlier on our calculator? Yes, but not yet, in a second. So try this one. I will, yeah, the data is there. So you need to determine what the median is, what quartile 1 is, quartile 3, interquartile range. All right, let's check how you did on the median. Did you figure out the median was going to be the 11th one? And the 11th one happens to be a 6. How do I know? Because there's 2 4s, then 5 5s, so that's 7 numbers, then 4 6s. A 6 will be the 11th one. For our lower quartile, 21 plus 1 divided by 4 is 5.5, so it's going to be the average of the 5th and the 6th one. The 5th one is a 5. The 6th one is a 5. The average of those will be 5. Now, quartile 3, if I take the 5.5 and multiply by 3, I get 15.5. No, I get 16.5, right? The 16th one is an 8. Right? 7, 11, 14, 15. 16th one is that. 17th one is also an 8. So quartile 3 will be an 8 as well. And then your interquartile range would be 8 minus 5. You just write it as a number 3. All right, try this one. All right. Does it make sense that if you added up all the frequencies, they would have to add up to 100? And if you added up all the other numbers except for k, you would get to 96. So then k has to be 4 because you're told there's 100 students. Now that you know that there's 100, can you find the median and interquartile range? Well, the median's position would be between the 50th and the 51st one. So the 50th one is a 3. The 51st one is a 3, so the median will be a 3. Quartile 1. If I add 1 to this and divide, I get 25.25. So quartile 1 will be the average of the 25th one and the 26th one. Quartile 3 will be the average of the 75th one and the 76th one. The 25th one is a 1. The 26th one is a 1. Quartile 1 is a 1. Let's see, 26, 36, 56, and 4, 60. Well, these are both 5s. And then your interquartile range is just 5 minus 1, which is 4.